Hello! Start tayo ng recap nung lesson natin last meeting about continuity nung sinimulan natin siya. So I have here a meme that, talks about several definitions of continuity from the most basic to something na very complicated. So let's start siguro baka nung grade 8, grade 9, ang definition or ang description sa atin na continuous ang isang function if you can draw the graph as a single unbroken curve or pwede mo i-draw yung graph without lifting your pen. Now, syempre, nag-start na tayo sa calculus and we've been introduced the concept of limits, so we will enhance our definition. So we say that a function is continuous at a, meaning ang tingin natin sa continuity for now is point by point. So at x equals a, yung function mismo continuous siya if the limit of f of x as x approaches a is equal to f of a, meaning pag in-evaluate natin yung function at a, it will be the same as the limit of the function as x approaches a. Now, yung definition na binigay natin na ito, no? Kung compare natin siya dun sa meme, parang siya yung second level ng definition natin. In our course, we'll probably get up to the third level. Beyond this, itong mga natitirang dalawang to, medyo advanced na siya. And actually, you probably won't encounter this unless you take up mathematics in university. Mga engineering ako, hindi naman namin ginamit itong concept ng metric spaces or worse topological spaces. Anyway, let's go back to our definition. Yung ginamit nating definition na to, no? Meron siyang assumptions na ginagawa. Like, for example, yung first implication niya is that f of a is actually defined, that you can actually evaluate our function at a, na may value yung function when x equals a. The second implication is that the limit of the function as x approaches a exists. Kasi we've seen naman examples from our lessons in limits na kung kailan hindi nag-exist yung limit, di ba? Well, of course, and finally, yung pinaka sinasabi natin is that the limit is equal to the value of the function when it is evaluated at a. Para masabi natin na continuous yung function at x equals a, these three things must hold. Visually, ito yung sinasabi niya. So, let's say we have our graph here, no? Itong kulay pink na to. Pag yung x values natin lumalapit dito kay a, then correspondingly, yung function na values natin lumalapit din ng papalapit sa point na to na ang y coordinate ay f of a. So, our y values are also approaching f of a. Meaning, the limit of the function is equal to the value of the function pag in-evaluate natin siya at x equals a. Now, syempre, if our function is not continuous at a, meaning may gap tayo or may butas yung function or you have to lift the pen pagdating mo sa x equals a, then ang term natin doon is that our function is discontinuous at a. So, yung formal definition, if f is defined on an open interval, so meaning meron tayong particular interval, no, containing a, tas maaring hindi defined yung function natin sa a kasi nga pwedeng discontinuous siya doon, no. Kung hindi nagho-hold yung lahat ng tatlong definition na to ng continuity, then our function is discontinuous at a. We classified our discontinuities as follows. Kung ang discontinuity ng function natin ay butas lang siya, no? So, let's take a look here. Kung butas lang siya dun sa function, ano yung nava-violate niyang condition ng continuity? In this case, the function is not defined dun sa x value where the discontinuity occurs. So, ito yung nava-violate niya. And for this discontinuity, the limit exists kasi lumalapit yung values ng function natin dun. Even though dun mismo sa point na yun, hindi defined yung function. So, syempre, hindi rin mag-hold yung third condition because the function is not defined whenever x equals a. So, this type of discontinuity, yung meron lang butas, ang term natin doon ay removable discontinuity. Kasi you can redefine the function to say na, well, kahit hindi siya defined dyan, edi when we'll define it, we'll add an additional definition na when x is equal to a, then it will contain this particular point. The second type of discontinuity is this one. So, again, no, if you're trying to draw, then you have to lift your pen para makomplete yung figure. So, hindi siya continuous. Now, dun sa formal definition, let's see the conditions. F of a is defined. So, yes. But here, the limit does not exist. Bakit? Kasi the left-hand limit will approach this value, the y value of that point, but the right-hand limit will be approaching the value of this point. So the left hand and the right hand limits are not equal, so the limit does not exist. So hindi na fulfill itong condition na ito. This type of discontinuity, well, yung descriptive natin na gagamitin ay if you're drawing your pen, you have to lift it or you have to jump papunta dito. This is called a jump discontinuity, or another term for that is an essential discontinuity kasi hindi mo siya basta-basta matatanggal. Now, let's take a look at this situation. Kunyari, ito yung ating open interval, no? And this is our A. Again, as we're trying to draw the function dun sa interval na yun, you have to lift your pen para pumunta dito. So, meron tayong discontinuity. Although, technically, hindi mo pwedeng i-lift yung pen mo, no? Kasi this will go on to negative infinity. Then, parang wala, hindi mo siya malilift para pumunta dito at i-drawing yung rest of the function. So this type of discontinuity is called an infinite discontinuity, and this is happening pag meron tayong vertical asymptote. So let's take a look kung ano yung nava-violate niyang conditions of continuity. Una, f of a is not defined in this case, kung kunyari ito yung a natin. Pangalawa, the limit does not exist kasi hindi equal yung left-hand side sa right-hand side na limits. Now, even if they're both approaching, no, let's say the same side, papunta sila parehong negative infinity, kahit sinasabi natin that the limit is equal to negative infinity, hindi naman totoong number ang infinity kaya positive or negative. So, in a way, still, hindi pa rin nag-exist yung limit. In fact, di ba, parang wala nga siyang limit, nasa infinity nga siya. And because of that, dahil wala tayong f of a at wala tayong limit, edi we cannot talk about the third condition. So here we have an infinite discontinuity. Now, this type of discontinuity, this is still an essential discontinuity. Again, maglilift tayo ng pen, drawing up, point, and then continue to draw. So may butas, may discontinuity. But again, you can redefine the function para yung point na to ililipat natin dito. So this is still considered a removable discontinuity even if f of a is defined, the limit exists, pero look, the third condition is not fulfilled. So these are the types of discontinuities that we will encounter. Yan lang naman. Yan lang naman when we're talking about continuity at a point. So let's take a look at some examples. Where are each of the following functions discontinuous daw? If we take a look at the first function, well, definitely we know that this will be undefined at x equals 2, right? Kasi yung denominator natin will be equal to 0 at x equals 2. So, this function is discontinuous at x equals 2. For our second function, we're looking at 1 over x squared if x is not equal to 0 and 1 whenever x is equal to 0. Anong itsura ng graph nun? I-recall natin. So, let's draw Cartesian plane. Yung graph ni 1 over x squared, well, this will be something like this, no? Diba? Mag-approach siya ng positive infinity as we approach 0 from the left. Then mag-approach din siya ng positive infinity as we approach 0 from the right. Now, whenever x is equal to 0, then our function is equal to 1. So, meron tayong point dito na y is equal to 1. By inspection, we could see that there will be an infinite discontinuity at x is equal to 0. In fact, yung definition mismo ng function, suggestive siya kasi nagpapalit siya ng definition sa x equals 0 Diba? So, dun ka na talaga unang titingin. Continuing with our example, if you will recall, itong letter C, pareho lang siya dun sa letter A kanina. Meron lang siyang additional definition na x equals 2. So, what we're doing here is we're checking kung baka naman na-fix na yung discontinuity. So, tingnan natin. Yung function na x squared minus x minus 2 all over x minus 2, that factors out to x plus 1 times x minus 2 all over x minus 2. And as we could see, we could cancel out yung factor na x minus 2 from both the numerator and denominator. This does not change the fact na may butas tayo at x equals 2. So, i-verify natin if nung dinefine natin yung function na f of x equals 1 if x is equal to 2, nafi-fix na ba yung discontinuity? Now, the limit of f of x as x approaches 2 is equal to the limit of x squared minus x minus 2 all over x minus 2 as x approaches 2. Bakit? Kasi hindi naman equal sa 2 eh. Yung x natin eh. When we're evaluating the limit, we're not evaluating dun sa 2 mismo. Dun lang tayo sa papalapit kay 2, both on the left and the right. So, gagamitin pa rin natin yung x squared minus x minus 2. And based dun sa nakita natin sa taas, no, na magka-cancel out yung dalawang x minus 2 factors, this is the same as evaluating the limit of x plus 1 as x approaches 2. And this is equal to 3. Now, f of 2, according to our definition, is equal to 1. So, the limit as x approaches 2 is not equal to the function evaluated at 2. 3 is not equal to 1. So, we still have a discontinuity at x equals 2. For our fourth example, we are looking at the floor of x. And from our meeting last time, we have seen na, well, saan ba siya mag-jump? We will have a jump discontinuity because the graph of the floor function looks like this. And the jump occurs whenever x is equal to an integer. So, our function is discontinuous whenever x is an integer value. For this example, ang instruction sa atin ay to redefine the function para tanggalin yung discontinuity. And looking at it, we could see that we should have a discontinuity whenever x is equal to 4. Kasi magiging undefined yung function natin at x is equal to 4. Now, to remove the discontinuity, kailangan natin mag-define ng function value whenever x is equal to 4. At dapat equal yun sa value nung limit of f of x as x approaches 4. So, isulat natin yun. Pero kung e-evaluate natin yung function at 4, we could see that ang makukuha natin ay 0 over 0 na form. So, in terms of limits, this tells us that meron pa tayong pwedeng gawin para mahanap yung totoong limit ng function. In our class discussion, ang ginawa ko ay biniyak ko yung x minus 4, no? Square root of x minus 2 times square root of x plus 2. But kung hindi natin makikita yon pero may nakikita yung square root, another approach we could take is to multiply by the conjugate nung may square root. So, I will multiply this by square root of x plus 2 all over square root of x plus 2. And this will give me a numerator of x minus 4. And our denominator would be the original x minus 4 times square root of x plus 2. Clearly, yung factors na x minus 4 sa numerator at denominator, they will cancel out. So, we could now evaluate the limit of the simplified expression, 1 over square root of x plus 2 as x approaches 4. Hindi na siya 0 over 0. Hindi na siya indeterminate form. And we could substitute yung 4 dun sa x. This will give us 1 over square root of 4 plus 2 or 1 over 2 plus 2 or 1/4. So, ang natitira na lang ay i-redefine natin yung bagong function natin. Tawagin natin f sub 1 of x to be equal to the original expression, square root of x minus 2 all over x minus 4, whenever x is not equal to 4, and for the function to be equal to 1/4 whenever x is equal to 4. So, meron pala siyang removable discontinuity at na-remove na natin siya by redefining the function. So, that should recap yung meeting natin last Friday. And dun sa next video, we'll continue with continuity and some theorems involving that, as well as some examples. So, thank you.